So, good evening, students. I hope you are all doing fine. Welcome back again. Today, we are going to start with a new chapter. As discussed, the last lecture will be starting with vectors. Now, I hope you got the update about the portion for the JEE Main January 2021. Today morning only we got the update. And what was that? Ki many of the syllabus is reduced. So in vectors also, the scalar triple product and the vector triple product are cancelled out. So first or this time we will not be studying STP and VTP here because it is cancelled out for JEE Mains 2024 January. Got it? So we'll get more time to do other important parts. And in 3D also there is some cancelled out portion and we'll look at it when we start with that. Good evening all of you again. Just tell me if the mic and all are audible. Am I audible and the video all is clear? Come on guys, give me a thumbs up. Yes, okay, superb. So I hope you are happy knowing the portion has been reduced. Many of the portion has been reduced from almost every chapter. Chalo. So let's start with vectors. First is we'll be doing introduction to vectors, obviously. Let's see what. One second. Yeah. Okay. Let's see. Start with scalar. I know. Starting में तो we'll don't get bored because we'll go through the theory. And if you have any doubt, you can ask. So let's start with scalar. As we all know, scalar is a quantity with only magnitude. You must have studied in physics this a lot. After this, we have a example. Like what are examples? Mass, length, temperature. You can go on and on and on. This is not important. We have vector. What is a vector? A vector which has both magnitude and direction. Here, vector is defined as a physical quantity. But remember, in mathematics, we do not use physical quantity. We represent vector geometrically. Now, this is used for physics, such as velocity, acceleration, force, and etc. So, vectors are represented by thick letters. This is a representation of vector. A bar is a vector, then its length is denoted by magnitude of A. These are the standard notations we use. Got it? So vector is denoted by small letters with a bar on it. We read it as A bar. Next is space vector. Space vector is generally the vector that we in mathematics use. That is in terms of coordinates. So generally physics mein physical quantities vectors are used, but in mathematics space vector is used. Here it is given that if three real numbers are A1, A2, A3, then point A1, A2, A3, or it is denoted by this, is not a point exactly, we'll talk about this later, is called a space vector. And A1, A2, A3 are the real numbers where A1 is the first component, second component, third component. Let's move on to the next part, which is length of a vector. So what is length of a vector? You can see if I have 2 points in space, that is A and B, and my direction of the vector is from A to B. So let's say suppose I have point A and I have point B. So basically in mathematics, I defined a vector as a directed line segment. Means vector is basically a line segment with direction. So here A and B are 2 points and direction can be either A to B or B to A. So if I give direction to this line segment, it becomes a vector. And now this vector is denoted by AB bar. A is a okay, superb. Chalo. So here I said it is called the chalo. These are some standard notation like equality of vectors. Now, if you remember, we also have equality of complex numbers. What are the equality of complex numbers? If two complex numbers are equal, then real part are equal and imaginary part are equal. Similarly, if two vectors are equal, that means the direction is equal as well as length is equal. So vector is made up of two parts, the magnitude and direction. So if we say two vectors are equal, that means they have the same direction and same magnitude, that is length. Next, free vectors. So basically in physics, we do not use free vectors. In physics, mainly we use directed vectors such as force. Force has a direction. If we change the direction of the force, then its effect also changes. Let me give a simple example. If this is a box landed, if I apply same 10 Newton force here, 10 Newton force here, 10 Newton force here, each of these direction matters because the object will respond differently based on where the force is applied. So in physics, we cannot use free vectors. Free vectors is mainly used in mathematics, or in mathematics, only free vectors is used, we can say. Because if a vector is in space, as in space vector, then we can move the vector freely anywhere provided the length and the direction is not changed. Provided length and direction is not changed. Good evening, good evening. Provided length and direction is not changed. So that is called a free vector. We can move the vector anywhere in space provided length and direction is not changed. Mainly used in maths, as I explained, cannot be used in physics. So let's see same which I said, independence of its position. So as I said here, we only talk about free vectors, or in maths, the chapter vectors will only talk about free vectors, correct? Let's move on to the next. Zero vector. Now basically we are entering into the types of vector. I hope you are of matrices, same thing here, types of vectors. We will not be like, we will go through many types. Just remember the name and you will get an idea of what type of vector it is with the name. Zero vector. Zero vector means the magnitude is zero. Next, same cheese. If this point is A, then A bar is a null vector because we didn't move from point A. So what is next? Next is unit vector. This is very important. You can see how very important it is by the number of varies. So why it is very important? Because basically, let us see first definition. A vector of unit length. Unit length means one unit length. One unit can be anything, 1 meter, 1 centimeter, 1 millimeter, anything. It's called a unit vector. Now, why I'm saying it is very important? Because as we know, vector is made up of two things, magnitude and direction. We all know the magnitude. That is, what is the magnitude? The length. Now, what is the direction, or what gives the direction? So, unit vector is also known as a vector gives vector which gives direction. Means a unit vector will give direction to a vector. So for example, if I want to define a vector, then I'll need two things, a magnitude of that vector and direction of that vector. Direction means and a unit vector. So from that only we have the famous formula of, suppose vector is a bar, then I can write it a bar as magnitude into direction of a bar, and direction of a bar can be written as a cap. Why a cap? Because direction is given by the unit vector. So I can write vector equals to magnitude into direction, and direction means unit vector. So from this, I can easily get the formula for unit vector, which is written here as a cap. A cap. I know. I hope you know the symbol for unit vector. The symbol cap or triangle, other triangle means it is a unit vector is read as a cap. So from here, I can see a cap is equals to a bar upon mod of a bar. That is a bar upon magnitude of a bar. So I can easily sum it up in general as vector is equals to magnitude into unit vector. So unit vector will be equals to vector upon its magnitude. These two formula, or rather one formula, we have to remember because it is a definition of vector. Vector is made up of two parts, magnitude and direction. Direction is given by unit vector. I hope it is clear till here. Correct? Let's move on to the next part. Next is co-initial vector. Co-initial vector means same initial point. It is such as this. These are two vectors, OA bar. This is OA bar and this is OB bar. Both have the same initial point, which is O. That means they are co-initial vectors. Here it is any two vectors can be taken as co-initial vectors. Why? Because here we have free vector theory. So any vector, this is some vector, this is some vector. Now I can move this vector here by free vector theory. Without these two vectors become co-initial vectors. So in mathematics, so vectors are said to be parallel. Now please remember here generally parallel and collinear are not equal. Why? Because two parallel lines are like this, but two collinear lines are like this, or collinear segments are like this. Point A, B, C, and these are two parallel lines. But in case of vector, parallel and collinear means the same thing because of free vector theory. So if these are two vectors, I can say these two vectors are parallel. I'll get this vector here behind this. So now these two vectors become collinear. So in case of vectors, parallel and collinear both mean the same thing. Parallel and collinear both mean the same thing. Therefore, it is given parallel or collinear if they lie on the same line or on parallel lines. That means let this be a line. There is a vector lying from point this to point this, and there is another line. There is vector lying from here to here. So these are parallel lines where vectors are lying on these lines, and parallel or A bar and B bar are parallel. Doesn't matter, either we use collinear or parallel, because in vectors it means the same thing. So A bar, B bar from diagram is parallel. If I move this vector here, this got it. Is it clear till here? Give me a thumbs up. Let me check if you all are sleeping or not. Because it's theory part, you might get bored. That's why I have to check every time. Come on, guys. Can we get a thumbs up if you are awake? All good? Clear till here? Hello, guys. Yes. Okay, super. Chalo. Let's move on to the next. Yeah. Now, from vectors, we can also see these are two vectors, AB bar and BC bar, which are either collinear or parallel. Here in this case, they are collinear. Since AB bar and BC bar mein B is a common point. Now, for 3 points to be collinear, they need to lie on the same line. Now, AB bar and linear and B is the common point. So that means that point ABC are collinear. That means point ABC lie on the same straight line. So collinearity of 3 points can also be proved by using vectors, by using collinear vectors. Now, enough about theory. Video is not clear. There are network issues here. I guess that's why. Now, is it clear? We are getting network issues from morning. From morning class, we are facing the issue. There is some problem with it. No. Clear ka hai ki is it like blur or is it like pausing in between? Okay. Let's wait some time, and once it gets clear, you same. Let's wait 30 seconds, 1 minute. Blur and pausing both. Okay. Because we had like around 4 or 4:30, there was no internet only here. So we'll cancel the class, but your luck and my luck both are opposite. I wanted to take the class. So it came, but I think it's still blur, okay? No, sir. Okay, fine. ठीक है. What can we do? Are others facing the same issue? We'll wait some time then. I think, is it fine now? Actually, this here mobile network also, sir, now it's clear. Okay, super. Chalo. So we can, where we were, we can prove 3 points collinear by using collinear vectors. Let's see. Same diagram I showed. If these two vectors AB bar and CD bar are collinear, that means A, B, C, D or the 4 points are also means, as we know, vectors have direction. So we can have two cases here. That is, two vectors are parallel but have opposite direction, and two vectors are parallel but have same direction. So you might know this. Such types of vector which have same direction are called like vectors. We have this question on like vectors here, and this are known as unlike vectors. If the vectors are parallel but have opposite direction, then it is unlike vectors or vectors. And if same direction, then it is like vectors. So yeah, we have here that only you can read it. Vectors if both direction are opposite. Got it? Now, what is this? You might have seen this first time, but in foreign author books, you will see that this symbol is used many times. In generally Indian authors or in Indian textbook, we do not use this symbol, but this signifies the angle between A bar and B bar. From physics, you must know how angle between A bar and B bar is calculated. Let me revise it for you. So suppose there are two vectors, this and this. So I can calculate angle between A bar and B bar only if the vectors are co-initial or co-terminal. What is meant by co-initial? Same initial point. What is meant by co-terminal? Same terminal point. So as you can see here, this is the initial point, this is the final point, this is initial, this is final. So these have the co-initial point. And if they are co-initial points, then this angle theta is called angle between A bar and B bar. Let us take another example where the vectors are like this. This is initial, terminal, initial, terminal. So here you can see both the vectors, these are not co-initial or co-terminal. In such cases, what we have to do by using free vector theory, we'll shift this vector backwards. So we'll get like this. So this vector is gone now. And now you can see this is the initial point, this is the terminal point, initial point, terminal point. Mean these vectors are actually co-terminal. So as you can see, let me draw with another color. 1 second. Yeah, this was the original vector. Yeah, so this is not the angle between the two vectors. This is the angle between the two vectors. You must know this from physics, but still we revised it. You can see the vector angle will be same, or we can calculate angle only if the vectors are co-initial or co-terminal. If they are not co-initial and not co-terminal, what we'll do, we'll use our free vector cross to make it co-A bar comma B bar, written like this. And this denotes angle between A bar and B bar. This denotes angle between A bar and B bar. Now you can see like parallel vectors, angle will be 0. Why? See this. By free vector theory, I can get this vector here. And you can see angle is 0. Got it? Co-initial co-terminal होना चाहिए ना. So basically these are not co-initial co-terminal. We can take this vector on top of each other. So I'll get two vectors like this. And you can see these are co-initial vectors. This is one terminal point, this is second terminal point. So let's name it. Suppose this is OA and this is OB. This is OA and B. As you can see, these are co-initial with O and not co-terminal. And what is the angle between them? It is 0 degree. That means co-initial vectors or like vectors have angle 0 degree. Same is for unlike vectors. If two vectors are unlike, then let me take the vectors like this. This is the initial point. This is terminal point for one, terminal point for two. So this is OA bar, this is OB bar. As you can see, both are parallel. I shifted them to collinear and reversed the direction. That means one is going outside, one is going right side, one is going left side. That means these are unlike vectors. And you can see angle between them is 180 degrees. So here angle between A bar and B bar will be 180 degrees for unlike vectors. Let's see next. Yeah. अरे okay. What is the next topic? It is angle between two non-zero vectors that we already talked about. So let's see what is angle between two non-zero vectors. Here same, I can calculate angle between two non-zero vectors if these are co-initial or co-terminal. And it is denoted by bracket A bar comma B bar like a point. So if either A bar and B bar is 0, obviously if any of the vector is 0, and we know that for a 0 vector, that is this vector, there is no specific direction. And if there is no specific direction for this vector, we cannot calculate angle made by it with another vector. So that means angle between 0 vector and another any vector will always be not defined. Will always be not defined. Now, we are on the next part of the chapter. 1 second, guys. I'll fix the. till the fine. Chalo. We are next part or starting with algebra of vectors. Now, algebra of vectors is very important because we have studied similar concepts, algebra of complex numbers, algebra of matrices. So basically, algebra means addition, subtraction, multiplication, and division. So we'll see all these four parts aram se. First is addition. So let's say two vectors are a bar and b bar, and there are 3 points. Obviously, we'll need 3 points to define two vectors a, b, and c. So these are 3 points. We formed three vectors a, b bar, b, c bar, and a, c bar. So if we want to add two vectors, then this is called the triangle law. This is called the triangle law. Triangle law says that if these three vectors are like this and the direction is as given as like this, then I can say AB bar plus BC bar is equals to AC bar. Now let me tell you one secret. Actually, every time while using addition of vectors, we do not generally need triangle law. Why? Because there is a fixed pattern. So see, if I don't know what is this equal to and someone says AB bar plus BC bar, so I can easily calculate why. See, here B and B is same. So if such situation arises, I can directly write this is equal to AC bar. So every time it is no need for us to draw triangle, but for the sake of understanding the triangle law, it is like mandatory, or we can use a triangle only for the first time. Let's have an example. Suppose I say BC bar plus CA bar. This will be equal to, come on, without using triangle. What will be BC bar plus CA bar equals to? Come on. BC bar plus CA bar. There are very important questions we are going to do using triangle law. And obviously those many questions are asked in previous year. So what is BC bar plus CA bar? Come on. BC bar plus CA bar. BA bar. Superb. Very good. It is BA bar. Why? Because C and C are same. That means my answer will be BA bar. No need to draw a triangle. This is the triangle law. Super. Chalo. Let's see what is next. Yeah, this is the triangle law. We talked about this. And same, the basic properties, the additive inverse and all. So we can see here, if A bar, B bar, C bar, three vectors, then this is the commutative property. अगर तीन नंबर को ऐड करना है तो पहले कौन से भी दो को करो फिर तीसरे को. Same with vector. If we want to add three vectors, add any two first. Second, A is an any vector, then A bar plus, obviously this is any vector plus a zero vector will always be the same vector. Here zero bar is called additive identity. What is additive identity? A number which when added gives the original number. So if I add zero bar in A bar, I'll get A bar. So if zero bar is added to A bar, I'll get A bar. That means this zero bar is called additive inverse. These are basically some like you can say theory or important parts. Like if in a question it comes कि additive inverse क्या है, तो तुम लोग को पता होना चाहिए कि additive inverse means what. That's why we are going through all this theory. And additive inverse, it is not that you are doing first time. You have done additive inverse, multiplicative inverse, and so on from school 9, 10 standard. So it's fine. And this is the AB bar plus BA bar. This is a commutative property. Why? 1 plus 2 add करो या 2 plus 1 add करो. Answer तो same ही आने वाला है. Now this is important. Third one. What third one says is a vector when multiplied by a negative sign. Suppose A bar is any vector and I multiplied A bar by minus sign. So what it does is the magnitude remains same. The magnitude of A bar and minus A bar remains same, just that the direction becomes opposite. The direction becomes opposite. So that means if this is A bar, so what will be my minus A bar? The magnitude will remain same, but direction will become opposite. So any vector when multiplied by negative, it just flips the direction, or it just the direction becomes opposite. So that means here this is A, but we already saw this example. And what does it do when we multiply the vector with a scalar? We'll see that, but let us discuss now as we have seen the direction. Suppose say I multiply this vector A bar by 5 times. So I'll get 5A bar. Now, as you can see, there is no minus sign. The direction remains the same. So what is changed? Change is magnitude. First, the magnitude was this much. Now the magnitude is 5 times of this. So this, when 5 times added, will give me 5A bar. As you can see, I can write 5A bar as A bar plus A bar plus A bar plus A bar plus A bar. Means if I add this 5 times, length will become 5 times of the original vector. So multiplication with a positive scalar will change the magnitude, and multiplication with a negative scalar will change the direction. Got it? Chalo. This is what we talked about here, that is scalar multiplication. You can see this. We discussed the same. Read it. I'll give you 1 minute. M greater than 0, M is positive. Then is a vector of length this. M times the original vector. And I have the same direction. But if it is negative, then it is a vector of length M only. लेंथ तो एम ही है ना, माइनस का फर्क पड़ा, माइनस खाली क्या कर देगा उसको, हैविंग अपोजिट डायरेक्शन. गॉट इट? चलो, लेट्स नाउ सी सम क्वेश्चंस. व्हाट इज द आंसर? These are some basic questions. As you know, we like to go through this question, so I can get कि हाँ आगे का तुम लोग को सब समझ में आया कि नहीं आया. Theory question only. This we discussed. This we discussed just now. Come on, what is the option? I don't think I need to explain this again. What is the option, guys? No one? That means you are not paying attention. What is the option? Hello? Am I audible? All good? Okay. 2. Superb. Very good. Since m is less than 0, then what is the direction of ma bar? Negative value will flip the sign, that is opposite to a bar. Let's see the next. Chalo. This is the basic notations. What is the answer of this? 3. Superb. Mod of a bar. Let's see next one. Chalo. This we discussed just now. Then 0 bar is called 2. Additive identity. Superb. Let's see what the position vector is. So here position vector is mainly important for us because we'll be using this many times, or almost every time in the chapter 3D. Position vector used to get position of a point. It is used to get a position of a point. Now let me tell you very important part. Suppose we are in 2D. We are in 2 dimensions. And I tell you to locate the point 1, 2. I'll tell you locate the point 1, 2. तो क्या करेंगे आप लोग? Basically, every one of you will first get the coordinate axis and get the origin. Because 1, 2 point makes sense only when origin is there. अभी किधर भी इधर ऐसा विदाउट यूजिंग ओरिजिन और विदाउट यूजिंग एक्स एक्सिस वाई एक्सिस 1, 2 लिख नहीं सकता ना. दैट मेक्स नो सेंस. So now if I have some diagram, I know कि 0, 2 1 इधर 2 इधर, so I'll get 1, 2. So what 1, 2 denotes? 1, 2 denotes the position of point P with respect to origin. 1, 2 denotes the position of point P with respect to origin. हम लोग with respect to origin बोलते नहीं है because it is by default. 1, 2 कोई point बोला, we by default make 0, 0 x y axis and we get 1, 2. Now same thing is done here in position vector. खाली नाम बदल दिए. Position vector भी क्या करता है? Used to get position of a point. Now position of a point, I didn't set with respect to what? Because position of a position vector में we can get a point with respect to another point. What I mean to say is, I hope you remember shift of origin. So suppose this is 0, 0. I'll take 3 points. This is 2, 1, and let's say this is 5, 5. Now I have written 2, 1 and 5, 5 coordinates with respect to origin. But let's say suppose मेरा axis यहाँ पे shift हो गया. So new coordinates of this point will be with respect to this point. Correct? New coordinates of this point will be with respect to this point now. What is new coordinate will be? 2 से 5 जाना है तो 3 चलना पड़ेगा. 1 से 5 जाना है तो 4 चलना पड़ेगा. So I got the same point with different coordinates. Why? Because this point 5, 5 was with respect to origin and this point 3, 4 is with respect to 2, 1. So similarly in position vector also we'll get two types of position vectors. One, to get position of the point with respect to origin and to get position of a point with respect to another point, which we did here. 5, 5 is position of a point with respect to origin. 3, 4 is position of this point with respect to 2, 1. I hope it is clear. So basically position vector gives position of a point. Now with respect to kya hai, that depends on the question or ourselves. So here, see, and how to denote now. Let's see how to denote. So let O be the fixed point. Now here we have taken O as origin and P is any point. Now I want to denote the position of P, but in terms of vector. So I can write OP bar. I can write OP bar. OP bar denotes the position of point P with respect to origin in terms of vector. So OP bar means, let me say how to read it. Position of P with respect to O. Position of P with respect to O. So if I write AB bar, so I can say this is position of B with respect to A. Position of B with respect to A. So here same thing, this is origin, this is A, this is B. This is position with respect to origin, this is position with respect to A. So basically position vector is denoted array. So point ka position can be given in terms of vectors. Chalo, let's see what we have next. Yeah, now important part. 1 second. Yeah, let me rub it out. What is meant by this? This is basically shift of origin formula. Shift of origin formula. If you remember shift of origin, we would write as x equals to x plus h, y equals to y plus k. So it looks like similar only, na? Vector equal to something minus something. So basically in terms of vector, let me write it as, see, OP bar, I am introducing another notation. if I want a position of a point with respect to origin. So there is no need to write every time OP bar. I can write OP bar as small p bar. I hope you know this. स्मॉल p बार का मतलब क्या है कि p की पोजीशन विथ रिस्पेक्ट टू ओरिजिन. अभी आई सेड ओरिजिन इज बाय डिफॉल्ट, देयरफॉर एवरी टाइम वी डोंट नीड टू राइट OP बार, वी राइट ओनली p बार. So if in a sum I am given a bar, so that means a bar is basically OA bar. That means it is the position of point A with respect to origin, which we do not say because it is by default. Here I cannot write this as B bar. Why? Because it is not with respect to origin. It is with respect to A. So how can I write AB bar? I can write AB bar as B bar minus A bar. What is B bar? B bar is position of point B with respect to origin. What is A bar? A bar is position of point A with respect to origin. Very simple. AB bar क्या करना है? Final minus initial. Final point B bar minus initial point A bar. So if someone asks PQ bar, what is PQ bar? Final point Q bar minus P bar. Small letters because small letters denote position with respect to origin. Got it? So it is very simple formula. No need to write every time OB bar, OA bar. Simply we can write with small letters. Got it? Chalo, that only it was given here. This is basically B bar. This is A bar. So AB bar can be written as B bar minus A bar. Now these are some, 1 second. Yeah, some theory or notation. You know all this. Out of this is very important. Please read all this except the last one. I mean, you can read the last one also, but you'll understand all this and I will talk some more about the last one. Got it? All this we have discussed already and some of them are like logical. So I don't think I need to explain. If you didn't understand any of this, you can ask me. चलो, अच्छा मैं बीच में आ रहा हूँ क्या? Okay. Done? 1 minute I'm giving. Most of this we have discussed, but if you didn't understand still, you can say. No need to remember this. It's basically common sense, you can say, right? Let's discuss this. If A bar and B are collinear बोलो या parallel बोलो फर्क पड़ता नहीं है. Then I can write A bar equals to KB bar for some scalar K. Now let's assume these are parallel vectors. This is A bar, this is B bar. Let's say the length of A bar is 3 and length of B bar is 6. So every time when two vectors are collinear or two vectors are parallel, they can have same direction or opposite direction. So I can every time get relation between these two vectors by just introducing a scalar. What I'm trying to say is, if I wanted to write B bar, I can write B bar as 2 times A bar. Why? See this too. If there is no negative sign, that means direction is same. And here it is 2 times. That means magnitude of B bar is twice the magnitude of A bar. You can see here clearly. Magnitude of A bar is 3, magnitude of B bar is 6. So I can always write two parallel or collinear vectors by introducing a scalar. So I can always get a relation between two parallel or collinear vectors by introducing a scalar. So this gives us algebraic way. अभी suppose मुझे question में हर बार थोड़े से vector बना के देंगे. They will not give me vector every time like this. What they'll give me is in terms of some equation or such. So if in a sum we see such equations, in general it is a bar equals to k times b bar, where k is a scalar. So अगर क्वेश्चन में algebraically ऐसा इक्वेशन दिखता है, so that means we can deduce that a bar and b bar are parallel. A bar and b bar are parallel. So this helps us in many ways. We'll see in the question, and also vice versa is also true. If it is given a bar and b bar are parallel, then how can we algebraically denote those vectors? We can denote it with a bar equals to k times b bar. Got it? So this is very important, and this is also called scalar multiple. I hope you have heard this word. Scalar multiple. It is also known as scalar multiple. Chalo, let's look at some questions. Chalo, do you know what the symbol means? This means angle between A bar and B bar. Chalo. What is the answer? We have discussed this also. Come on, guys. Very simple we are doing. A, B, C, D option. We have discussed this answer also. Right, guys? One. Superb. Like parallel vectors के बीच का angle 0 degree. We have discussed. I am not discussing again. Okay, this is an interesting sum. Nice question. Just let me tell you, this question is based on the last part which we discussed. What was the last part which we discussed? Collinear vectors ka part we discussed, right? So that use that logic here. This is a good question actually, very good question. After you give me the answer, I also want to know the reason, but you cannot, how will you tell me the reason? Fine, it's fine. Just tell me what you think is the answer. Come on. 3. Okay. Chalo. Niranjan said 3. Superb. It is the right answer. I hope your explanation is the same which I'll give. See, A bar and B bar are given non-collinear vectors. Now, we know that I can write A bar equals to K times B bar only when the vectors are collinear. So if the vectors are not collinear, that means I cannot write A bar equals to K times B bar. See this? X is a scalar. I can divide by X. I'll get A bar plus Y upon B, Y upon X. B bar equals to 0 bar. 0 को X से divide किया क्या फर्क पड़ता है? Now this is basically A bar plus KB bar equals to 0 bar. Or I can say A bar equals to minus KB bar. So this equation basically reduces to this. Now look at this. I can only write it like this if A bar and B bar are collinear vectors. But in question it is given non-collinear. That means we got a contradiction. So if we got a contradiction, that can only mean one thing, that both X and Y are 0. Put X and Y 0 here, it will satisfy this. If X equal to 0, I'll get 0 plus 0. 0 plus 0 is 0, and right hand side may be kya hai? 0. So only one condition will satisfy this equation apart from the condition that the vectors are collinear, that is X equal to Y equal to 0. Both should be equal to 0. Then I'll get this. Clear? Give me a thumbs up. This is a very important question because there will be a more superb question asked in JEE Advanced on this concept. Means the question was like very good, but we had to use this part in that question, this small part. Got it? If it's clear, give me a thumbs up. Come on, guys. All clear? Chalo. Let's see the next. I think we have not discussed this, right, till? let's skip this. Yeah, this one is for you again. What is the answer, guys? Come on. Simple. 2. Super. Unlike parallel vectors, matlab angle is 180 degree. Chalo. What does this mean? This means angle between A bar and B bar. So they are saying angle between A bar and B bar will be equal to this. Come on. Simple question. What will be angle between A bar and B bar equal to? Nothing. अरे क्या तुम लोग ये ए बार ये बी बार ये दोनों के बीच का एंगल दिया है थीटा तो ये किसके बराबर होगा बी बार और ए बार के बीच में है गाइस व्हाट आर यू डूइंग अरे एंगल बिटवीन ए बार एंड बी बार इज एज गुड एज एंगल बिटवीन बी बार एंड ए बार क्या मजाक क्वेश्चन था ये तो डन फॉर टुडे लाइक ऑल फेड अप सिंपल इट वाज ए बार एंड बी बार के बीच का एंगल इज एज गुड एज बी बार एंड ए बार क्या करता है लेट्स गो नेक्स्ट okay let's do this question as the last one you might have gone through this question many a times and these are one of the most important question asked or frequently asked questions here abcd is pentagon if the sum is lambda times AC bar, that means they are saying AB bar plus AE bar, all these vectors का sum plus BC bar plus DC bar plus ED bar equals to lam अच्छा plus ED bar plus AC bar भी है plus AC bar equals to lambda times AC bar. मुझे क्या फाइंड करना है lambda. Now this is a classic question of triangle law. अभी ट्रायंगल लोग कैसे क्लिक करेंगे अरे वेक्टर ऐड हो रहे हैं ना भाई वेक्टर्स आर गेटिंग एडेड देखो ए बी बार से ऐड हो रहा है और जैसी वी सी एडिंग एडिशन ऑफ वेक्टर्स व्हाट वी थिंक ऑफ इज ट्रायंगल लॉ सिंपल what we think of it is triangle law. So you already lambda equals to 3 superb very good so triangle law I said there is no need to draw triangle every time if AB bar plus BC bar. So this is B and B is same. This is equal to AC bar. So what I did is see, I'll group AB bar BC bar. So AB bar plus BC bar और बाकी के तीन this and this. I'll write it AE bar plus ED bar plus DC bar और ये लास्ट में प्लस AC bar is equals to lambda AC bar. See this? This is equals to AC bar plus ये देखो E और D सेम हो गया. That means this is equal to also AC bar and here we already have AC bar equals to lambda times AC bar. So 3 AC bar equals to lambda times AC bar. ऐसा AC AC कट नहीं होता है वेक्टर में वेक्टर कैन नॉट बी कैंसल्ड बिकॉज इट ऑल्सो हैज डायरेक्शन वी थियरी की बात कर रहा हूं इफ यू आर इन थियरी पेपर एनसीईआरटी डू नॉट कट इट what can we write by equality of vectors two vectors are equal that means their magnitude here magnitude is 3 here magnitude is lambda will also be equal that means lambda equals to 3 you have to write such statements in theory exam your board paper your pre-board is coming right when is your pre-board when is your pre-board starting in December which date is it starting do you all know pre-boards when are your pre-board starting December 5 and until which date it is December 5 to यू डोंट नो द एंड डेट क्या? अभी तक टाइम ही नहीं मिला है देखने का, इतना बिजी पढ़ाई में. यस, December 5 to I think 15 it is, right? यस सर. किसके लिए था? 15 के लिए कि नहीं? बहुत पढ़ाई कर रहे हो उसके लिए? ठीक है. एनीवेज, आई होप यू गॉट दिस. बोर्ड्स में ये सब लिखना जरूरी है. व्हाट? कि बाय इक्वालिटी ऑफ वेक्टर्स वी कैन से लैम्डा इक्वल्स टू 3, दे मे कट मार्क्स. सो आई होप इट इज क्लियर टिल हियर. फुल बिजी. हाँ. And we'll end it today. We'll continue tomorrow. We have some questions left of this. Same hexagon भी है ना? We'll do question on hexagon. Parallelogram भी है. So we'll do some questions there, and then we'll end our session tomorrow. So thank you all for joining. Let's meet again tomorrow. Bye bye. Take care everyone. Tata. Bye bye.